Welcome to Solving Systems by Substitution. Let's get started. And a quick reminder about system of equations. Remember that a system of equations is just two or more, and that there are three possible solutions you can get. One solution, which is where they intersect, no solution, which is when they're parallel, or infinitely many, which is when the equations are the same line. Now there are multiple ways to solve a system of equations. Last time we learned how to solve them by graphing. Remember, graphing manually on paper or graphing with your calculator. Now we're learning a new way to solve a system of equations, which is by substitution. Now substitution is exactly how it sounds. We want to substitute something in for one of these variables. Remember, a solution to a system is always written as an ordered pair, so we're looking for an x and a y. So as we look at these two equations, we want to find out what x is and what y is. With substitution, you need to get one of these equations into y equals or x equals. You want to isolate a variable by itself. I'm going to do the first one because it's the easiest. When you have y plus 4 equals 3x, if you can subtract this 4, move it to the other side, you'll have y equals right away. So that's what we're going to do. So we have y plus 4 equals 3x, and when we subtract the 4 over, we end up with y equals 3x minus 4. So all we did was subtract the 4 from both sides, minus 4, minus 4. Now we can substitute 3x minus 4 in for the y of this second equation. Okay, so let me show you how that looks. We have 3, and instead of putting the y here, we've got the first equation that tells us what y is, 3x minus 4. So we put here 3x minus 4. And then we keep writing with the rest of this equation. Equals 15x plus 6. Now you just need to solve for x. See, we've gotten rid of a y. Now we can find what x is. So we distribute 3 times 3x is 9x, 3 times negative 4 is negative 12. And then we still have 15x plus 6 over here. Now we can, let's see, I'm going to subtract this 9x. We need to combine our like terms. And that cancels this out. We still have negative 12 here. And then we have 6x plus 6. And now we can subtract this 6 because we're still combining our like terms. Get the numbers together, and this cancels. And you have 6x equals negative 12 minus 6, which is negative 18. Since we want x by itself, our final step is to divide by 6. And we get that x equals negative 3. So we know what x equals. Now we want to know what y is. So since we have an x, we can go back to this first equation right here, where we have y equals 3x minus 4, and substitute this negative 3 in for this x, because it tells us x is negative 3. So now we just put negative 3 here. So y equals 3, and then instead of putting the x, we put negative 3. And then we keep writing, minus 4. And then we just solve. 3 times negative 3 is negative 9 minus 4. And that's still y equals. So that means y equals negative 13. So we have an x and we have a y, so we can put it as an ordered pair. Negative 3, negative 13. So this is our intersection point. If we were to graph these two, we would find that they intersect at negative 3, 13. But we didn't do it graphing, we did it algebraically through substitution. So as a quick summary, remember, we want to isolate a variable. That just means get one of those equations into x equals or y equals, whichever equation looks easiest to do. Then substitute whatever that was into the other equation. So you're getting rid of a variable. Then just solve. And we're going to have plenty of time to practice these problems in class so you can really get it down. Don't forget to watch the next video where we learn another way to solve system of equations. Thanks for watching and see you soon.